Hi, today I want to go ahead and help with some of our application problems for our 6 trigonometric functions. So you're going to notice I have a diagram here, but I'm going to go ahead and read the word problem for you first. So in one area, the lowest angle of elevation of the sun in winter is 25 degrees and 16 minutes. So you'll see sun, right? We have our angle of elevation here. Now you'll see that in the next part of the prompt it'll say to find the minimum distance x that we have here that a plant needing full sun, so in other words it always has to have sunlight, can be placed from a fence that is 4 9/4 feet tall. So in this case, one of the first things that we need to think about is how can we solve for x and what trigonometric functions might be able to help us. So let's take one step back from that and think about what pieces of the triangle we actually already have access to. So one of the first pieces of the triangle that we have is the opposite of our angle, as well as the adjacent leg of our angle. So in this situation, I have opposite and adjacent. Is there any trig function that rings a bell for opposite divided by the adjacent? Hopefully you're thinking tangent. So I'm going to be using the tangent of theta, opposite divided by adjacent, to come up with my answer for this problem. So I'm going to take tangent of our theta, which in this case is going to end up being the 25 degrees and 16 minutes. That's going to be equal to the opposite, which is 4 9/4, divided by the x, which is the adjacent side length. Now, before I do any mathematical calculation or put anything in my calculator, I like to get the algebra out of the way first. So one of the first things I'm going to do is try and isolate this x. One of the first things that I think about doing is multiplying both sides by x. So I end up with x times tangent of 25 degrees and 16 minutes equal to 4 9/4. Now you might be thinking, well, that didn't really help. Gets us one step closer. Now I can actually divide by our tangent of 25 degrees and 16 minutes to the other side, leaving me with x equal to 4 9/4 divided by tangent of 25 degrees and 16 minutes. Now in this situation, I can actually go ahead and place this into my calculator, but there's one extra thing that we need to think about, this 16 minutes. Now, in the past, we've done this. So we're going to take our 16 minutes, and we know that this is equivalent to taking 16/60, which will give us our degree measure. So in my calculator, I can go ahead and write the following, or type in the following. So I'm going to take 4.94 divided by tangent of 25 plus 16/60. Notice how I put parentheses around that. Now, once I have that information, I can go ahead and come up with my decimal answer. Now, the decimal equivalent in this situation ends up being approximately, or sorry, actually 10.46640,638 feet. Now, if this is going to a standard homeowner or we're trying to figure this out for some sort of customer, then we kind of have to think in terms that they might actually use. So this might be a little bit hard for them to digest if you tell them, well, this is how far your plant needs to be away. How are they going to come up with that? So rounding kind of helps with that for a better estimation for the consumer. So thinking about that, I want to round to this decimal place. In order to do that, I need to look right next door to it where the 6 is. This 6 will tell me whether or not I'm going to round up or down. Since this is a value of 5 or greater, which is 6, I'm going to round up. So x is approximately equal to 10.5 feet. And you can make these approximates. So in this case, we know that the minimum distance that this plant can be away from the wall in winter is going to end up being 10.5 feet approximately. Hopefully you found this video helpful in working with application problems for your 6 trigonometric functions.